It almost seems too simple to be true. Silicate rock, during the natural process of breaking down in soil, draws carbon from the air, helping to absorb greenhouse gases and potentially offsetting the impacts of climate change. University of California researchers are studying how that process can be applied in agricultural fields to boost carbon sequestration, or the collection and transformation of atmospheric carbon dioxide into solid carbon.
Specifically, what we're trying to evaluate is a practice called enhanced rock weathering. And this practice essentially mimics Earth's process of regulating climate, Mother Nature's process.
Enhanced weathering involves pulverizing rock into dust, which increases its surface area, thereby speeding its ability to bind with atmospheric carbon. For centuries, farmers have added rock dust to soil as an amendment, as a way to infuse mineral nutrients. But using rock dust in farm fields for carbon capture and sequestration is a relatively recent innovation.
This is a really new practice for agriculture. The studies that have been published are showing that there is a drawdown of carbon from the atmosphere, but they can't necessarily tell us how much carbon we're removing.
O'Geen has a research team made up of scientists from UC Davis Institute of the Environment, Lawrence Livermore National Laboratory, and UC Sierra Foothill Research and Extension Center. They have developed a monitoring system as part of a first-of-its-kind study designed to measure how much carbon is sequestered by this practice.
No other study in the world is doing that, and that is essential to be able to incentivize this practice, because if we know how much carbon we took out of the air, we can monetize that. Carbon markets can invest in the practice, and that can support growers, ranchers in implementing the practice in the future at large scale.
On irrigated pasture at UC A&R's Sierra Foothill Rec in Yuba County, researchers added pulverized rock dust to several fields. As rain and irrigation water move through the soil, the water collects carbon dioxide from the atmosphere, creating a weak acid. That acid breaks down the rock dust, and all the products of that breakdown, including carbon pulled from the atmosphere, are then captured by the soil and eventually washed into streams and out into the ocean, where it can remain sequestered for thousands of years.
We need to find mechanisms to draw down the carbon dioxide that's in the atmosphere and lock it into places that it will not exchange with the atmosphere. So essentially bank it into other locations so that we can draw it down from the air. And that will hopefully lower the global temperatures and reduce climate change.
To measure the carbon sequestered in this process, O'Geen devised a series of trenches cut into the slope of the pasture.
We have holes in the ground on a steep hillside, and we have carved away at the face of the earth to allow a vertical soil surface, and we have injected metal plates into the soil at various heights and attached water troughs, so to speak, like rain gutters, and it flows, it captures the water that infiltrates through the soil, gets onto the tray underground, and then flows into the trough and go through a tipping bucket to measure volume and then out again.
Count the number of tips, and you get the volume of water moving through the soil. Multiply that volume by the concentration of carbon in the water, and you get the total mass of carbon that has gotten locked up moving from air to soil and out to waterways. And even though the rock was applied just last year, researchers are reporting initial positive results.
Obviously, rock takes a long time to weather and dissolve fully, but we're already seeing evidence of atmospheric carbon drawdown in the soil water solution of landscapes that have been treated with pulverized rock. So we're seeing it is making a difference. What makes this project so special and unique is that we're able to leverage the human capital and research infrastructure at the Sierra Foothill Research and Extension Center. We would not be able to do this by ourselves on private land or public land because the people that are here have the skill set to build the monitoring equipment that we need. They have the skill set to manage the ranch exactly like a rancher would manage it, but allow us to conduct the research that we need to do to answer the questions we need.
Schweitzer says that the project has produced not only valuable insights on improving irrigated pasture, but also challenged the REC staff to adapt and innovate.
Our crew is able to support all those causes. How? Well, we have the machinery, we have the brain power, we have the passion, We have the employees that have stick-to-itiveness.
The researchers are also looking at differences between untreated pastures and pastures with the pulverized rock amendment, which provides other benefits that boost plant growth, such as increased soil pH and added nutrients. Adding pulverized rock could also complement other healthy soil practices. For example, mixing it into compost could boost microbial activity and accelerate the enhanced weathering still further. Only 1 year into their research project, the scientists were recently informed that they had lost their federal funding. But, O'Geen said, they are committed to continuing this crucial study for at least the next 5 years.
We're sure going to be studying these soil landscapes the rest of this summer and next winter and the following summer, and then hope to find more money to continue to study all the soil health benefits in the future.